There will be 4 free response questions on the AP exam. This practice problem is modeled after FRQ 3. Let's pretend it's from the 2014 exam. If you appreciate this content, please give it a like. A prize wheel used for a game show has an electronic motor that allows a circular wheel to spin at a constant speed in the clockwise direction until a contestant presses the stop button, which is not shown. The center of the wheel is 30 inches away from point A. This is point A. At time t equals 0, A is directly below the center of the wheel, and the distance between A and a level table is 20 inches. The wheel completes 4 full rotations every second. As the wheel spins, the distance between A and the level table periodically increases and decreases. The sinusoidal function h models the distance in inches between A and the level table as a function of time in seconds. Part A. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P, are labeled on the graph. No time scale is indicated and no axes are presented. Determine possible coordinates t, h of t for the 5 points F, G, J, K, and P. Let's start by building a vertical scale. At its lowest, point A is 20 inches above the table. So this will be 20. The midline will be 30 inches above that at 50. And then the highest point that A will reach will be 30 more inches above the midline. So that will be 80. Applying the vertical scale to our graph, we have a low at 20, a midline at 50, and a high at 80. This gives us the output coordinate of all 5 points. Now we just need to find the input coordinate of each point. At time t equals 0 seconds, point A is directly below the center of the wheel. So at t equals 0, point A is at a low point. Therefore, we need to pick a low point and call it t equals 0. For example, we could call this t equals 0. If we do that, the input values to the left will be negative numbers. There's nothing wrong with that, but I don't care for that, so I'm going to choose a different option. I prefer to extend the graph one more mark to the left. Now I can call this low point t equals 0, and all of my other input values will be positive. The period comes from this sentence right here. The wheel completes 4 full rotations every second. If the wheel completes 4 rotations in 1 second, it will complete 1 rotation in a quarter of a second. And 1 rotation is the period. So we now know that the period is 1/4 of a second. The period of 1/4 second gives us the time between the starting low point at t equals 0 and the next low point at point J. So this point must be t equals 1/4. If this point is at t equals 1/4, then halfway will be t equals 1/8, and half of that again will be t equals 1/16. We can use the first value after 0 to find all of the missing input values. Because the first value is 1/16, the second value will be 2/16, which reduces to 1/8. The third value will be 3/16. The fourth value is 4/16, which reduces to 1/4. The fifth value will be 5/16. The sixth value will be 6/16, which reduces to 3/8. Now we have all of the input coordinates and all of the output coordinates. So let's make a list of the coordinates of the 5 points that we needed. Point F is at 1/8, 80. Point G is at 3/16, 50. Point J is at 1/4, 20. Point K is at 5/16, 50. And point P is at 3/8, 80. And that's it for part A. Part B. The function h can be written in the form h of t equals a times the cosine of b times t plus c plus d. Find the values of constants a, b, c, and d. You need to memorize what the graphs of these two parent functions look like, y equals sine t and y equals cosine t. In this case, h of t is an image of cosine t after 4 transformations. Notice that the sine function starts at the midline and then goes up and down like this. So if we were to trace a portion of the sine function on this curve, it would look like that, or like that. Since h of t is a transformation of the cosine graph, we're going to start at a high point and then go low and back to a high point like this. So let's highlight one period of the cosine function on the graph, like this. Let's build an expression for h of t, filling in the values of a, b, c, and d as we go along. The a value is a vertical dilation. So let's compare the height of the parent function above the midline to the height of h of t above the midline. The parent function has a height of 1, while h of t has a difference of 30 from the midline to the high point. So that's a vertical dilation by a factor of 30. Therefore, the a value is 30. I'm going to save the b value for last. I'm going to come back to that. The c value indicates the horizontal translation of the graph. So we see that compared to the parent function, h of t has a horizontal translation of 1/8. Normally, the parent function starts at 0, but this period of cosine starts at 1/8. The horizontal translation always shows up as the opposite of what it appears. So, with a horizontal translation of positive 1/8, we put minus 1/8 in the function. So the c value is negative 1/8. By the way, in the context of periodic functions, a horizontal translation is called a phase shift. So instead of saying that the graph was horizontally translated by 1/8, we say that the graph has a phase shift of 1/8. The d value indicates a vertical translation. So notice that the midline of the parent function is 0. Compare that to the midline of h of t, which is 50. That tells us that there has been a vertical translation of 50. h of t must be shifted up 50 compared to the parent function. So the value of d is 50. How about that b value? That's the only thing missing. I want you to memorize this b value formula, which works for sine and cosine. b is equal to 2 pi divided by the period. Back in part A, we found that the period was 1/4 of a second. Therefore, the b value is going to equal 2 pi divided by 1/4. When you divide by a fraction, you multiply by the reciprocal. So this will equal 2 pi times 4. So the value of b is 8 pi. And we can just fill that in right here. On the AP exam, you are allowed to leave your answer to part B just like this, with the A, B, C, and D filled in to the expression. However, they will provide you with an answer box like this. So you are free to record your answers in the answer box like this. but you do not have to. If you do use the answer box, this is what will be graded. But again, you are allowed to just leave your expression for h of t with the values of a, b, c, and d filled in like this. Part C. Refer to the graph of h in Part A. The t-coordinate of f is t1, and the t-coordinate of g is t2. In other words, this is t1, and this is t2. See Part 1. On the interval from t1 to t2, which of the following is true about h? Is it positive and increasing, positive and decreasing, negative and increasing, or negative and decreasing? On the interval from t1 to t2, h of t is clearly decreasing. H of t is falling from left to right on this interval, but is h of t positive or negative? Well, just look at the output values on this interval. They are between 50 and 80. So the output values are all positive. So the answer is B. H of t is positive and decreasing on the interval from t1 to t2. C. Part 2. Describe how the rate of change of h is changing on the interval from t1 to t2. Back in Unit 1, we learned that if h of t is concave up, the rate of change is increasing, and if h of t is concave down, the rate of change is decreasing. On the interval from t1 to t2, h of t is concave down. Therefore, the rate of change is decreasing. They did not ask us to justify our answer, so it's probably safest to answer with a single word. Just say decreasing. Part D. Find the period, frequency, amplitude, and midline for the graph of h. The period is the horizontal length of one cycle, which is 1/4. The frequency is the reciprocal of the period, so that's 4. The midline is the horizontal line halfway between the highest value and the lowest value. In this case, the midline is y equals 50. Don't forget the y equals in front for midline. What about the amplitude? The amplitude is the difference between the highest value and the midline. 80 minus 50 is 30. So the amplitude is 30. Remember, the amplitude is always positive. Part E. Find two intervals for which the graph of h is both decreasing and concave up. To complete this task, we're going to need a couple more input values. So let's stretch out this scale. The first value after 0 represents 1/4 period. We can count by the quarter period to find any unknown values. This is 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, and 8/16. Obviously, 8/16 reduces to 1/2. Now, we are looking for two intervals where h is both decreasing and concave up. H is decreasing on these two yellow intervals. H is concave up on these two blue intervals. H is decreasing and concave up on these two green intervals. That's the interval from 3/16 to 1/4 and the interval from 7/16 to 1/2. So this is the answer to Part E. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.